Okay, here we're going to look at other types of problems that we could tackle with what we've learned so far from our z-scores and z-score formulas. So let's say that we know we've got a population with a mean of 65 points. And we know that within this population, if someone had got a raw score of 59, that's the equivalent of a z-score of -2. So that if they are at a 59, they are exactly 2 standard deviations below the mean. What we want to know is, what was the standard deviation? So we're going to tackle this problem both ways. We're going to do it first in a graphic format, and then we're going to check it with a formula and see. So let's start by plugging in what we know. We know that the mean is 65 points. What we would ordinarily do is then number off these lines using the standard deviation, but we don't know it. That's what we're trying to figure out. But what we do know is that if you go 2 standard deviations below the mean, 1, 2, that raw score is 59 at that location. So think about what we figured out here. We have figured out that if we go 2 standard deviations below the mean, that is the same thing as going how many raw score points? Well, 59 to 65, that's 6 points. So 2 standard deviations is the same thing as moving 6 points. We move 2 standard deviations, we moved 6 points down. So if 2 standard deviations is worth 6 points, what's 1 standard deviation worth? Well, obviously divide both by 2, and we find the standard deviation is 3. So we did that without a formula. Pretty easy problem set up. We didn't really need a formula for it. So every time you move a standard deviation, you move 3 points. So 65 down by 3 is to 62. Down by 3 again is to 59. But let's take a look at that using the formula. As I indicated earlier, for anything other than solving for z, I like the raw score version of the formula instead. So again, let's use that version of the formula. Plug in what we have, solve for what we don't. Well, the raw score we already know is at 59. The mean we know is at 65. Oops, I want to put an equal there. The z we know is -2. And standard deviation is what we're solving for. Well, it's just straight up algebra at this point. We want to get rid of the 65 over there, so we subtract both sides by 65. So 59 minus 65 is -6. We have -2 next to our standard deviation. We want to get rid of that. Divide both sides by -2. And we end up with the same answer. So again, it's ultimately, of course, you really need to know how to work with the formula. That's the biggest piece of it. But if you can see it graphically and you can get it through the calculator answer, you're really set up for good success. You really are having the topic pretty well nailed down. Let's do a different version of the same style of problem. Word scooching on me. Let's say for this problem, we know that the standard deviation is 6 points, that if you have a raw score of 33, the equivalent z-score is 1.5. And so now what are we missing? We're missing the population mean. So what we want to figure out is, well, what was the mean for that data? So again, let's start with sort of a graphic approach. We don't know what number to put here at the moment. That's what we're trying to figure out. We know that the distance between lines is 6 points. We know that if we go up 1.5 standard deviations, so up 1 and another half, that is a raw score of 33. So let's think about it. If we have moved 1.5 standard deviations up, one standard deviation is worth 6 points. So moving from here to just there, that's 6 points. And then what? We move another half of a standard deviation, because it's 1.5 standard deviations above the mean. One standard deviation is 6, so a half of a standard deviation would be 3. So what do we know? We know that we've moved a grand total of 9 points away from the mean. This entire distance is 9 points. Well, if the raw score is 33 here, and we go backwards to the mean by 9 points, that's how many points we've traveled, 33 minus 9. So we know that the mean for our score is, for our data rather, is 24 points. So now let's look at it with the formula. So the raw score is 33. The mean is what we're trying to determine. Z is positive 1.5. Our standard deviation is 6. So our 6, we multiply that by our 1.5, that gets us 9. To cancel that 9 out, we subtract 9 from both sides. And again, of course, the same answer. So I know I've already said it a couple times, but just to reaffirm, work on it so you at least feel comfortable. You're certainly going to have a preference for doing it one way or than another. Again, we can really only kind of sketch our way to answers here when the answers, when the data works out as relatively easy to manage in your head sort of numbers. If the numbers start to get dense with decimals and other stuff, forget about graphics and just go straight to your calculators is what I would say there. So with this, we're essentially done talking about the first purpose for z-scores. We've really taken a bit of a dive on describing a person's exact location within a distribution, and then did some other ways of encountering the processing of this data. So what we're going to look to next then is that second purpose, transforming an entire distribution, typically to make more easily make comparisons. So we'll start that in the next segment.